Here are your video notes for lesson 4.2. And lesson 4.2 is about using linear equations in slope-intercept form. And the tools that you will be using, I'm referring to them as tools. These are things that you've learned to work with. Will be slope-intercept form, which is y equals mx plus b. It'll also be the fact that slope is equal to rise over run. That's for when you work with a graph. And if you work with two given points, you'd be using the equation that m, or slope, equals y2 minus y1 over x2 minus x1. If we take a look at what's in your book, you don't have to copy any of this down, but lesson 4.2 starts on page 232. And as I said, it is using linear equations in slope-intercept form. The thing is that'll be new. We're going to use a linear equation to actually find the y-intercept today. The problems will not give you the y-intercept. There is a concept summary in your book on page 332, and it shows this as a three-step process. Step one being that you'll identify the slope. You'll have to calculate the slope possibly using the slope formula, or you may end up using that slope is equal to rise over run as well. Okay, we already wrote that down. After you get the slope, you'll have to end up finding the y-intercept today, and that'll be new. And this goes on to say you find it by substituting the slope and the coordinate points x and y on the line into the equation y equals mx plus b, and then solve it for b. The third step will be at the end. You'll have to then write the equation in slope-intercept form, where you're going to insert something for the slope and put something in for b as well. Also in your book are guided practice problems, and these are after the examples. You could look back at the examples if you wanted to, if you need some more help. But for example 1 in our notes, let's just do what they ask us to here. It says, write an equation of the line that passes through the point 6, 3 and has a slope of 2. So if we start the problem off by saying we're going to go through the point 6, 3, and we're going to have the slope of 2, what we're used to is that we work with y equals mx plus b. And from the other day, you should know that the 2 that you see right here is going to go in for m, and you're going to have that y equals 2x plus b. Now what we have to look at is, how do we find out what b is when this point is not the y-intercept? And the key thing we will do is we will recognize the 6 is the x-coordinate. It goes in the x right there, or right here is where we're going to replace it. And the 3 is the y-coordinate, and that will be going in for y, because this point is on the line of this equation. So as we continue working, I'm going to bring the 3 down for y, have it be 2 times the 6 plus b. And to solve this now for b, I can do that because b now is the only variable there. 2 times 6 is 12. I'll bring down the plus b with it. That's going to be equal to the 3. To get b by itself, I subtract 12. I subtract 12. This zeroes out. I get negative 9 here. I bring my equals down. I bring b down. b equals negative 9. Now realize we are not done yet, because the actual thing it says to do is to write the equation of the line. So the equation of the line still needs to get written as y equals something times x, and put the y-intercept in as well. And we have the slope right here, so we get y equals 2x. We have the y-intercept right there. That becomes minus 9 there. So that is now our equation as far as our answer for example 1. Looking ahead to other ones that you might see examples of, these are guided practice 2 and 3 from your book. So if we go through a second example now, it says write an equation of a line that passes through this point and this point. So let's put those 2 points down. 1, -2, and -5, 4 in your notes. The first thing we will need to do is we'll need to calculate the slope, and we're going to calculate the slope using the equation that m equals y2 minus y1 over x2 minus x1. And we're putting in our notes when you do your problems. If you do not copy that down anymore, that's okay with me. Here is my y2, so I'm going to put that here. I'm going to subtract from it y1, which is right there. And under it, I'm going to put in my x2 value of -5 minus the other x1 value, which is 1. If we change this to adding the opposite, this is going to turn into 6 on top. And if we change the other one to adding the opposite, it's going to turn into a -6 on bottom. Color there, and that will equal a -1 for our slope. Now we do have our slope to put in, so in the equation y equals mx plus b, I'll put the -1 in, and in order to find b, I have to fill in 2 values for x and y. And it won't matter which point we use, whether we use this point or this point. I would look at this and realize these 2 numbers look like they're a little smaller than the other numbers. They'd be easier to substitute in probably. So I'm going to bring the 1 down and substitute it in for x, the -2, and substitute it in for y. And it won't matter which point you use, you'll still get the same answer for the y-intercept. -1 times 1 is 1, plus b is equal to -2. If I add 1 here and I add 1 here, we will get that b is equal to -1. So now we're ready to write the equation for it, where we would be saying y equals the slope times x, and put the y-intercept in for that. Our slope is -1, and our y-intercept is -1. So we get y equals -1x minus 1. However, most of the time, this 1 is probably not going to get written in here, so we will erase it. And what you really would get is the equation that y is equal to -x minus 1. So example 3 will be one I'll let you work ahead on your own if you pause the video after we get it set up. Looking at what you have here, we have that f of -2 equals 10, and we have f of 4 equals -2. And I'm hoping now that you recognize you don't have to write what I'm putting here in red, but this is an x value, this is a y value, this is an x value, and this is a y value. So this really amounts to the coordinate point -2, 10, and this is the coordinate point 4, 2. So it gets done just like the other problem. Why don't you pause the video now, you work through, get your answer for what the equation would be, and unpause it to see if you have it right. Welcome back from unpausing the video. To calculate our slope now, we should have 2 minus 10 on top and 4 minus a -2 on bottom, which when we do the math of this, changing that to adding the opposite, do I have stuff set up right? Because I think this should come out to a whole number. Put the 2 minus the 10 on top, the 4 minus the -2. Oh, it looks right. But this is going to give me a -8 over 6, and that's a -4/3. So I'm setting something up wrong. Oh, that's supposed to be a -2. So this is actually -2 right there. Nope, I'm sorry, that's negative. That's going to now give me 12. Hopefully you think it's funny when Mr. McDowell screws up. The negative 2 and the negative 10 give me negative 12. This still comes out to 6, and this is now a negative 2 for a slope. Alright, so I'm doing it correctly at that point. And then now we are going to work with the equation y equals mx plus b. Put our negative 2 in. I got to put an x value in, find what the y-intercept is, pick which pair of points I think would be easiest to put in for x and y. Smaller numbers look like they're those. And it will be to put in negative 2 for y and put the 4 in for x. So as I continue working now without another mistake, negative 8 plus b is equal to negative 2. Add on the 8, add on the 8, b equals 6. So now my equation in slope-intercept form will be, put the y-intercept of 6 in, that's there. The slope that we had calculated is up here, put that in there, and we have an equation in slope-intercept form where we used y-intercept form to actually calculate the y-intercept, and that's this step right here that we were doing. Alright, so that concludes your video notes, and we'll see you tomorrow.